Hello, math fans. This next chapter is called the polar unit. Okay, so we're going to be working with polar equations and polar graphs. And actually, before we even get into that, before I discuss too much about it, day one is really a review of something we learned in Algebra 2. And it's basically complex numbers, imaginary numbers, and doing some of the arithmetic to multiplication, division, etc. of those types of numbers. So that's pretty much what the today is, just review. So let's start out with a complex number. Okay, so complex number has two parts. It has a real part. So this is a plus bi. So this is your real part, and this is your imaginary part. All right, so first of all, we call this the rectangular form. And we're going to talk about polar form later on, but it's just an example is 3 plus 4i. That's 3 plus 4i. That's a rectangular form of a complex number. And just remember, just kind of a way to remember it is the real part is first, and the imaginary part is last. That's really important. It has to be in that form. Okay, so if you gave me an answer of 4i plus 3, you would lose some points for that because it's not in, we call that standard form. It has to be in standard form. Very, very important. And the way I have kids kind of remember that from Algebra 2 is just remember, if you have some M&Ms, you want the real M&Ms closer to you. You want them first, and you want the imaginary M&Ms, the fake M&Ms, farther away. Okay, so let's kind of remember that. Real part first, imaginary part last. Okay, so let's talk about what an imaginary number is. As you saw, it wrote a plus bi. And if you remember, the value of I represents the square root of -1. So if I have the square root of -25, the first thing you do is, well, let's kind of break it up. It's really saying -1 times 25. And so what you want to do then, and I'm going to just show you a little bit of work here. Square root of -1 times the square root of 25. And so the square root of -1 is I. Square root of 25 is 5. So you write that just like you do a variable. The answer is 5i. All right, so pretty easy. But the key is when you have a negative, you got to take out an I. Okay, this is the only time you don't get in trouble for taking out an I, because usually you get in trouble when you punch somebody and take out an I. Okay, this way you take out the I first and you're okay. Nobody's going to get you in trouble. In fact, that's what I want you to do. Then you will not be in trouble. Okay, let's do some solving equations. If I gave you this x squared equals -25, well, we take the square root of both sides, and we get x is equal to, and don't forget, this is huge, people, plus or minus the square root of -25. And then we just simplify that, as we actually just did up here. So really the answer is plus or minus 5i. Okay, so let's do a few more here. If I give you x squared plus 4x equals -11. Well, okay, we can move the 11 over, so let's get x squared plus 4x plus 11 equals 0. Well, the only thing that goes in 11 is 11 and 1, and that's not going to give you 4. So, well, we got to use the quadratic formula. And you guys remember the quadratic formula? The x equals opposite of b plus or minus a square root of b squared minus 4ac all over 2 times a. Hey, so it's the same thing. So we're going to do x equals opposite of 4 plus or minus the square root of 4 squared minus 4 times 1 times 11. All over 2 times 1. Okay, so that's going to give us x equals negative 4 plus or minus 16 minus 44 all over 2. So x equals negative 4 plus or minus the square root of negative 28 all over 2. So x equals negative 4 plus or minus, and well, it's definitely 7 times 4. We can take a 4 out of there. And then, of course, we have an I. So it's plus or minus 2I root 7 over 2. Now, if you left it like that, you cannot leave it like that. I told you it has to be split up. Okay? You have to have the real part and imaginary part. Right now, that 2 owns both, and it's got to be separated. So you need to write it as negative 4 over 2 plus or minus 2I root 7 over 2. Then, of course, you simplify your fractions, so your final answer is negative 2 plus or minus I root 7. Okay? Final answer. And it's in standard form, because I is last. Those imaginary M&Ms are farther away, so that's perfect. All right, so let's talk about powers of I. Okay, you guys, everyone teaches it a little bit differently. This is the way I like to teach it. I think it's very straightforward. Some people learned it as I to the 1, I to the 2, I to the 3, I to the 4, and then you dealt with it from there. I do it from I to the 0, because anything to the 0 power is 1. I to the first, well, anything to the first power is itself. And the only one that's a little tricky now is I squared, and you remember that's negative 1. And I to the third power, well, isn't that just negative 1 times I, or negative I? Okay, those are really the 4 you need to know, and I really like those exponents, 0 through 3. The reason I like those is, this is the rule that I made up. The rule, okay, is you have I to a power. And what you're going to do with that power is you're going to divide it by 4. And you're going to have a remainder. I don't even care what the number is. I mean, it could be divided by 4. That it could be, 5,000 remainder or whatever. I'm only concerned about the remainder. So remainder, it's either going to be a 0, a 1, a 2, or a 3. And hey, look at that, huh? Wow, it kind of matches up there, which is actually really, really good. So the remainder is 0. It's I to the 0, which is 1. If the remainder is 1, it's I to the 1, which is I squared, which is negative 1, and I to the third power is negative I. That's all you need to be concerned about, is just the remainder. Okay, so let's just do a couple examples. Yeah, we'll fit it all on the screen here. I to the 23rd power. Well, I'm just going to do 20... my calculator, 23 divided by 4, that's going to give me, if you did it in your calculator, it's going to give you 5.75. Okay, and you need to realize, you guys are all smart kids, that it's a remainder of 3. So that means it's just I to the third power, and I to the third power going up here is just negative I. That's the answer to that problem. Okay. Okay, what about I to the 105 power? It's 105 divided by 4, and that's 26.25. And you can even know that too, right? It's got a remainder of 1, because 104 is even, or is divided by 4 is, a remainder 0, so it's got a remainder of 1. So there it's just I. I to the first, or I, right? Okay, I to the 200th power. Well, that's really nice. I know that one's remainder 0. I mean, I guess I could write it out, but it's, I'll do that. 200 divided by 4 is 50, and it's got a remainder of 0. So that's just I to the 0, which is 1. Okay, so that's how you do all the i's. No matter what I, you just divide it by 4, and whatever the remainder is, that's your exponent, and then you go from there. Okay, it's pretty mellow. Okay, let's do some operations now. If I give you the square root of negative 6 times, oh, well, hey, the negatives cancel out, square root of 60, boo. Okay, you can't multiply negative radicals. First thing you have to do is you got to get rid of the I, or you got to take out a negative 1 to give you an I. That is really huge. So even before I start the problem out, I'm just going to go, okay, well, it's I root 6 times I root 10. So I times I is I squared, and that's 6 times 10. Yeah, I don't know how you guys learned it back in the day, but I hate to multiply 6 times 10 when I know I automatically can take out a 2. So 6 times 3, oops, I'm just going to write 2 times 3, and 10 is 2 times 5. I just like that a lot better, because then I can say that's I squared. Well, first of all, I squared is negative 1, so I'm going to write negative. Take a 2 out, and you got 15 left over. There's your answer, negative 2 root 15. Same thing with division. Square root of negative 6 over square root of negative 10. So remember, you can't just say, oh, well, the negatives cancel out. You got to pull an I out first before you can do any operation. So it's I root 6 over I root 10. And again, I don't know how you learn. Well, first of all, the i's cancel here now. That's pretty sweet. I don't know how you guys learned it with radicals. You could just rationalize it by multiplying top and bottom by root 10. Or, remember, that's the same thing as 6 over 10. So we can even simplify it right here. So it's going to be 3/5. So now I got square root of 3 over square root of 5. So I can rationalize that. And I don't really care however you learned it. If you want to multiply square root of 10 over square root of 10, I'm just trying to show you, I think, the easier way to go about it. So we get square root of 15 over 5. And please, please do not cancel things out and say the answer is square root of 3. All right, because that 5 is not under a radical, the 15 is under a radical, so nothing cancels out there. We are done with the problem. That's your answer. Okay. So let's, if I give you a problem like x plus yi, this is actually pretty easy. 5 minus 7i and 1 plus I. And what I'm asking you guys to do is find x and y. So you just FOIL it out. That's all you do. So 5 times 1 is 5 plus 5i minus 7i minus 7i squared. And just remember, I squared is negative 1, so it's really 5 plus 5i minus 7i. And since this is negative 1, it's plus 7, right? Because negative 7 times negative 1, positive 7. So you wind up getting 12 minus 2i. Notice it is in standard form. And then, of course, the answer to this problem then is, what is x? Well, x is the real part, so x equals 12. Y is the imaginary part, so it's negative 2. Not negative 2i, it's just negative 2. All right, so that's that one. Let's do just some basic operations here with complex numbers. So 7i minus 6 minus parentheses 2i minus 4. All right, so just make sure you distribute the negative both places. So we get 7i minus 6 minus 2i plus 4. 7i minus 2i, 5i minus 2. Everybody agree with that answer? Are we all good? Right? Yes? Boo! Wrong order. Negative 2 plus 5i. That's your answer. Okay, it's got to be in standard form. Okay, so let's do a little multiplication on the side here. 3i minus 4, 2i minus 1. So if I FOIL that, 3i times 2i, 6i squared, minus 3i, minus 8i, plus 4. Okay, remember I squared is -1, so that's -6 minus 3i minus 8i plus 4. So -6 plus 4 is -2 minus 11i. It's in standard form, and that's your answer. Okay, let's do division of complex numbers. So 2 minus 4i over 3 minus 2i. And remember, I'm not allowed to have a radical in the denominator, which I represents the square root of -1, so I need to get rid of that I. And what I do is I multiply by the conjugate. So if you guys remember conjugate, so it's 3 minus 2i, the conjugate is 3 plus 2i. Okay, so make sure you multiply the top and the bottom. 3 plus 2i. And the top, you FOIL it out. So 3 times 2 is 6, plus 4i, minus 12i, minus 8i squared. On the bottom, we get 9. Remember, the outside and inside cancel. That's the whole point of conjugates. The outside and inside cancel, and we have to multiply by the last. So it's minus 4i squared. And we got to simplify our I squareds. So that's going to be 6 plus 4i minus 12i, and that's going to be plus 8 because I squared is -1. So it's plus 8. And bottom, that's going to be plus 4. So we have 14 minus 8i over 13. Is that our answer? Actually, it's close, but it's not because it's not in standard form. The imaginary part and the real part have to be separate. So the answer is 14 thirds, or 14 thirteenths, minus 8i over 13. That's your answer. Okay, not too awful. And that's it. That's you have a couple of complicated problems in your homework, and I'm going to let you guys do the one complicated problem. Okay, so that's it, math fans. Have a nice day. Goodbye.